idea? Well, let's look. What is the main function of motor control? Upright position, person state, and lift hand to the side. What happens with center mass? Center mass shift, weight shift, but person doesn't fall because muscle tone changed by brain signals immediately and keep body mass in stable position to maintain balance. The main function of muscle tone to keep balance, to keep posture at rest or during walking, during every moment. What receptor sense, what receptors sense change of body position and head position. Receptor of body and receptor of head. Receptors. Receptors are responsible for motor control. Receptors. Body. And head receptors. More important receptor located in muscle. In muscle and in tendons. They are called proprioceptors. Proprioceptors. Proprio means proper muscle receptor, proper receptor of somatic system. Sometimes proprioceptors includes all somatic receptor with skin receptors, but we will consider proprioceptors only as receptors of muscles, tendon, and joint. Proprioceptors, say names receptors. What is proprioceptors? What are proprioceptors? Do you know? Name of proprioceptors.
It's a Golgi tendon receptor.
Golgi tendon organ and Golgi tendon organ and second. What receptor do you know? If you are not prepared to class becomes not effective. I don't have much time during grading. I have a lot of students to ask you one by one. You have a good chance to come to me in autumn because central nervous system motor control is very complicated topic. What receptor next? Muscle spindle. Muscle spindle. Muscle spindle. What receptor, additional receptor, helps to control muscle tone? Joint receptors, Pacini, for example, joint receptors. Temporomandibular joint, for example. Oral area, temporomandibular joint, example. And skin receptors. Skin receptor, touch receptor, temperature, pain receptor, fast mechanoreceptors. For example, during pain, we have defense response, withdrawal. Withdrawal, of course, it's called muscle contraction, so it's controlled by motor system, brain motor system. And head, at head we have receptors, one type of receptor, more vestibular receptors. Vestibular receptors. What stimuli evoke vestibular receptors? What stimuli? What stimuli are adequate to evoke vestibular receptors? how to excite them. How to excite vestibular receptors. Did you study vestibular system, sensory system in Aristotle, and how to excite? What stimulus excite vestibular receptors? It's a school program. Vestibular apparatus, vestibular receptors. What is necessary to do to excite vestibular receptors? Main nervous system allowing to keep balance. And
So,
open textbook and study. If you don't prepare it, I will not give lecture again. Study. What do you think? At rest, when you are not speaking. Why? Your mouth closed. Because that person, when that person, mandible lift down. Mandible move down. In that person. But in you, no. Why? You think about closing or no? Why? In living person, at rest, without eating, speaking, mouth is closed. And that person, mandible move down.
Because the muscle is stretched.
Yes, because muscle has tone, muscle tone, with gravity force. Mandible moves down, it stretch muscles, masseter, it excites receptor, muscle spindle, and provoke reflex, increasing muscle tone, and we have muscle closed mouth with small distance between lower and upper teeth. This distance is controlled by tonic reflexes, mostly from muscle spindle. So it's important in even for your future profession, not only for neurology and diploma. What level of brain is enough to have muscle tone of body muscles? What level of central nervous system is enough to have at least some muscle tone in the body, skeletal muscles? Is it enough to have spinal cord?
Sometimes, yes.
Yes, it is enough. Of course, with cutting of head, human death. Human will die, but in some animal you can do this experiment, or a spinal injury, spinal cord injury, also change muscle tone. But muscle tone will be even after spinal cord injury. Total spinal cord injury, it requires only spinal reflex up to maintain lowest muscle tone. Of course, for muscle head, it's necessary to have brainstem. So spinal reflexes are background to provide muscle tone. Spinal reflexes are controlled by motor system located in the brain. Which is spinal reflexes. I said that we have many receptors. We studied receptors, somatic reflex arc, previous class. At the previous class, reflexes from skin, withdrawal reflexes. Withdrawal reflexes, polysynaptic reflexes. Today we must study reflexes from proprioceptors, specific proprioceptors, muscle spindle, and Golgi tendon organ. Two key questions for this topic. What happens in response to muscle stretching? What happens in response to muscle contraction? One type of proprioceptors detects degree of stretching. Another type detects degree of contraction, shortening. So we have two conditions of muscle, lengthening and shortening. Lengthening and shortening. It's so simple. I don't understand why do you have problem with control work. Background condition. Cases. Stretching or lengthening. Stretching. First. Second, contraction. Shortening. Two cases. What receptor responds on the first condition? In the first condition. What receptor resides here for the first case? In the first case.
Muscle spindle.
Muscle spindle responds to detects muscle spindle detects stretching. What receptor detects muscle contraction?
Golgi tendon.
Golgi tendon organ. Because tendon is stretched more in response to muscle contraction. Muscle contraction shows muscle length and it pulls tendon tissue. Stretching of tendon excites Golgi tendon organ. About structure of receptors. Muscle spindle has a complicated structure compared to Golgi tendon organ. Muscle spindle located inside capsule or fusus. Is formed by connective tissue. It surrounds intrafusal muscle fibers with back nucleus, nuclear back, and nuclear chain. One type of muscle spindle contains wide central part with a lot of nuclei inside, and another more thinner with nuclear chain. Not so important. This detail is not so important, but I must explain because it's a better background. What is the name of these muscle fibers? Inside capsule. Name.
Intrafusal.
Intrafusal. Why it's called so? Because inside fusus. Intrafusal. Contractile muscle fiber around. In opposition calls
Extrafusal.
Extrafusal. They provide contraction, muscle contraction and force. Intrafusal muscle fiber are surrounded by spiral nerve ending, like spiral form. What is the type of nerve ending?
1A.
Primary A.
Primary.
A, afferent ending. Afferent ending located at the center of the muscle intrafusal muscle fiber. They are more sensitive, more excitable, and rapidly adaptive. Not alpha, primary A. Afferent. Primary A, afferent. Another type of afferent ending is located at the distal part. Here, at the distal part. It's called second. During stretching, central part is stretched more stretched. So it excites more primary A. With long-lasting, strong stretching, secondary will be excited also. So short term little stretching excites only primary A. Long lasting, and stronger stretching excites both. But primary A adapt faster, and with long-lasting stretching, firing of primary and secondary becomes equal. Yes. At the first moment, only primary A becomes excited, and then with prolonged stretching, secondary respond too. Reflex. Reflex arc. Reflex only, we draw and study reflex only from primary A. Muscle spindle, work part of muscle spindle. In scheme of reflex arc, we draw only work part, intrafusal muscle fiber with primary afferent ending, and show spiral form to mark primary ending. Sensory neuron located in dorsal root ganglion, then afferent fiber enters into spinal cord, gray matter. Dorsal horn doesn't relay here because this reflex is monosynaptic and conveys information directly to ventral horn, and here relays directly to alpha motor neuron. Alpha motor neuron. Alpha motor neuron. Alpha motor neuron innervates extrafusal muscle fiber, triggering their contraction. So, in response to stretching, muscle tone increases. Muscle tone increases. More stretching, more increases. With rapid, strong stretching, you can see muscle contraction, visible muscle contraction and movement. With small stretching, only muscle tone changed. Then, this is intrafusal muscle fiber. My hands are extrafuses. It's a background condition. Then strong stretch. What happens with muscle? Muscle has reflectory reflex contraction. And what strong contraction? What happens with intrafusal fibers?
Will be short.
Shorter and weak. Then I stretch muscle a little. It doesn't work because weak. So what is necessary to do? It's necessary together with muscle contraction, contract intrafusal muscle fiber. What neuron has this function?
Efferent.
What neuron stimulates intrafusal muscle fiber? Increase tone of intrafusal muscle fiber.
Efferent.
What efferent? Name. What type of motor neuron? Alpha motor neuron innervates extrafusal muscle fiber. What neuron innervates intrafusal muscle fiber?
Gamma.
Gamma. Gamma motor neuron, smaller motor neuron, smaller body. It innervates intrafusal muscle fiber and control their tone to adapt to muscle contraction, to keep sensitivity, to maintain sensitivity of receptor work part, gamma motor neuron. Of course, alpha motor neuron has afferent type of nerve fiber A alpha, and gamma, what type of nerve fiber must be?
A.
A.
A what? Gamma motor
Gamma.
neuron. Gamma, easy. And afferent primary A also type of A alpha. A alpha type is the fastest type of nerve fiber, fastest. Solitary. A alpha. So somatic reflex use fastest nerve fiber, and somatic response usually is faster than autonomic response, because autonomic nervous system uses another type of nerve fiber, B and C. The somatic response is very, very fast. Well, with stimulation only A gamma, can we change muscle tone? Extrafusal fiber. For example, you want stimulate only A gamma fiber, or only gamma motor neuron. Can this stimulation increase muscle tone and provoke muscle contraction or not? If you stimulate only gamma motor neuron,
I think no.
no, it's possible
It's possible.
due to gamma loop. Gamma loop. Gamma loop. Remind that A gamma fiber innervates intrafusal fiber at distal parts. Distal parts. So, activation of gamma motor neuron stimulate distal part, they contract, it stretch center, and stretching of center stimulates, excites stimulates primary A fibers. A gamma synapses, intrafusal muscle fiber, stimulation, distal part contracts like this, because becomes shorter. Shortening of distal parts stretches central part. And primary A becomes Z. And then we have regions. It's called gamma loop. Gamma loop. Usually brain, normal brain, sends signal to the spinal cord, to the motor neuron, simultaneously together to gamma motor neuron and alpha
Alpha.
motor neuron both. It's called co-activation. Co-activation. Do you understand why it's necessary now?
Yes.
Yes.
To maintain sensitivity of intrafusal muscle fiber, sensitivity of muscle spindle, and excess of gamma, it's excess of gamma motor neuron activation, or disorder balance between excitability, gamma, and alpha motor neuron can provoke spasms, not only in the body, in the oral area also. And spasms can change masticatory activity. It can change position of temporomandibular joint, then provoke inflammation and destruction. It can change normal pattern of mastication and digestion. Motor asymmetry. Therefore, it's very important to understand motor control. Motor control for your future profession in oral area because it can cause disorder for motor control, can cause problem in oral cavity and with masticatory system, with teeth also. For example, what last previous week conference, Perlov conference, and our student, my previous student, the writing student, Vahid Ansari, do you know? He did report and had prize, won prize, third place, with the scientific report about asymmetry of healthy student, young persons with absence of caries problem, with teeth, with mostly healthy with healthy teeth. And anyway, 50% of our group, we studied 10 volunteers. 10 volunteers, 50%, 5% had problem with asymmetry, stable asymmetry during chewing, independently of light, independently of size of chewing. Asymmetry with mastication. Even in healthy young person, then it's possible to have problem. So you must understand what reason may be for these disorders in motor control. Then this reflex. And example of reflex from muscle spindle, knee jerk reflex, knee jerk or patellar reflex. And the same. There are some similar tests in neurology with light type of hammer, neurological hammer on tendon. You can impact on tendon of quadriceps, Achilles tendon here, on the hand, but more famous, knee jerk reflex. Knee jerk reflex. Knee jerk reflex, quadriceps. What is a quadriceps? Quadriceps flexor or extensor? Quadriceps. What is a muscle? Flexor or extensor?
Extensor.
Extensor. Extension. Flexor here. Extensor. It's extensor. Quadriceps. It has tendon above knee cup, covering knee cup. More or less approximate position of tap hammer, impact of hammer. Impact of hammer, stretch tendon stretch muscle. What does stretch more? What stretches more in this case? Tendon or muscle?
Tendon.
Muscle.
Muscle,
It's
because
muscle.
tendon is more rigid tissue. Muscle is more stretch, it has more elasticity. It excites muscle spindle, primary A, sensory neuron, and monosynaptic reflex. Excites muscle contracts, and you can see movement of leg. This is knee jerk arc, reflex arc. Draw the schemes are copied in your textbook, notebook.
This one, right?
Yes. Draw these two schemes. And I will check, verify. Draw only simple scheme without reciprocal inhibition. Simplified scheme, the base, without reciprocal inhibition. Reciprocal inhibition I explained to you in the lecture. Well, show me. What is the effector here? Where synapse? Where synapse must be? No, it's receptor. Where must be synapse? Alpha motor neuron. Where? Synapse, synapse. 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 Where synapse? Synapse. Synapse must be on the extrafusal muscle fiber. Synapse. Synapse means this. Synapse. Where? Where synapse? Synapse on the nerve intake. Where? No. Here. Not on the receptors. Not at fiber. Near. On the muscle. No.
Я стоял, расмаушка, стояли сюда, мش
Well, I will show more clearly. Synapse of alpha motor neuron must be on extrafusal fiber, not on intrafusal. Intrafusal fiber are innervated by gamma motor neuron, but here, alpha motor neuron. Synapse inside muscle, not on receptor. Understand? No. The more the muscle. Spinal. Oh. Synapse must be must be distant. Well, not inside.